Hey everybody, before we get to the cerebrum, which is on this slide, I want to review a few things that Mr. Davis was talking about to add some things, maybe give some other ways to learn some stuff. The reticular activating system, Mr. Davis mentioned that it was net-like. That's where reticular came from. Good way to remember it. It's that pencil thing. He talked about the pencil inside of the brainstem. What does it do? It's reticular activating system and reticular formation. I've seen it described as both. You can pick whichever one. Sometimes on the test it'll say reticular formation. Just remember reticular is the most important. Reticular activating system. What does the RAS do? Reticular activating system. It says to rise and shine. RAS. Rise and shine. So it wakes you up and it puts you to sleep. RAS. Reticular activating system. Rise and shine. I know it's stupid, but stupid mnemonics work better. Same with medulla. I've seen medulla oblongata and I've seen medulla. Same thing. Don't need to worry about that. The hippocampus, one mnemonic I have for that is why are the hippos wandering all over campus? They can't remember where their classes are. So the hippos are wandering all over campus because they can't remember. Hippocampus is remembering where your classes are. And then the last thing before we move on, if I don't mention this in class, please, and Mr. Davis, if he doesn't either, remind us to tell you to download 3D Brain. It is an app. You can do it on your computer, you can do it on your phone, but it's a really cool app to see these things that we're talking about that you can't really see in 2D. It's free. If you just search 3D Brain, you will find it. Okay. Now we talked about the cerebellum back here. Mr. Davis was mentioning that here in the back of the head. That means little brain. Cerebrum means brain. So we're going to look at this big part. I think it's like 75, 80% of the weight of your brain is right here in the cerebrum. So we looked at the reptilian brain. If you really look at it this way, it's like you have your brainstem here, and then you have your limbic system right here, which is a lot of emotion and memory. And then you have your cerebrum on top. And basically what I've heard is if you put your two fists together like that, that's about the size of your brain. And if we have time, I'm going to show you a video of a dissection of a brain. It's pretty cool. But anyway, so the cerebrum is that outermost, the part that you see, the part that you're seeing right here on the screen. And the outermost part of your brain is called the cortex. Cortex is Greek. We're doing the Mr. Davis etymology thing. It means bark. So the cortex is like the bark on the tree. It's the outside part. So the outside part of your brain is the part that has so many of those neurons. And what happens is, as you are creating synapses, as your neurons are connecting, as you're learning more and more, your brain doesn't get bigger. What happens is it folds more. It needs more space. The way I think about it is, how do we get more space in a piece of paper? How do we fit this into a small space? We fold it. What if we need more connections? What if we need more space? We fold it even more. So what we find is when we say, look at Albert Einstein's brain, his brain was not bigger than anybody else's. It had more folds. It was very, very deep because you would learn. Your brain changes when you learn something. It changes shape. Pretty cool stuff. So we're going to look at what the cortex is. This is the big stuff. I can't believe Mr. Davis keeps leaving me all the good stuff. Okay, I probably should have worked the other way, but this is fine. We're going to work from the newest, probably to the oldest part of the brain, the frontal lobe. Really, couldn't they have thought of a better name for it, really? I mean, this isn't the basal lobe. Why is this the frontal lobe? Whatever. And this is the prefrontal cortex right here. This is what makes you, you. I think your book talks about Phineas Gage, who got the pole through his eyeball, and it basically damaged his frontal lobe. He lost the ability to control himself. He was cussing. He was showing up late. He couldn't control his impulses. So all of the things that your brainstem and your limbic system are telling you to do, your frontal lobe says, wait, hold on a minute. So it's this, but the problem is your brainstem and your limbic system work really fast and your frontal lobe works really slow. And one of the great books by any neuroscientist ever is a book called Thinking Fast and Slow by Daniel Kahneman. And basically it's this brainstem and limbic system is the fast part, your frontal lobe is the slow part. But without the frontal lobe, we wouldn't have cathedrals or symphonies or anything like that. And we're going to talk about a really important part of the frontal lobe right here, but we'll get to that in a little bit. Parietal lobe. Parietal means wall. It's named after this big bone in your head. There's a parietal bone, which is basically one of the biggest bones in your skull. So it's like this big wall. The parietal lobe is where you have your somatosensory cortex. And we're going to talk about that on a slide coming up. There's a particular part of your brain that if we took off the top of your head and we just sent a little electric pulse into the somatosensory cortex, I could make you not only feel something in your finger. I could also make you move your finger. And I could say with a fair degree of certainty, I can make you move your left foot. I can make you move your right wrist. I mean, it's really that specific. So we're going to look at these two parts right here. The somatosensory cortex is going to be right there. And there's a lot of spatial relationships going on here too. So we are very, very good at maneuvering in space. And that's partially because of our parietal lobes. Why do we hardly ever lose our way in our home? Why do we have such great spatial abilities? It's our parietal lobe right here. Okay, and then our occipital lobe, which is kind of weird. It's in the back. The way I remember it, it's almost like light coming in your eyeballs gets shown on the movie screen in the back of your head. That's your occipital lobe. That's where our vision is. It goes through the thalamus. So we're going to look at a graphic later. It's crazy. I believe it's in chapter 4. Just how complicated it is in getting information from your eyes to your thalamus to the back of your head. But pretty much that's all your occipital lobe does. And we're going to look later too at something in your brain. There's a particular part of your occipital lobe that only allows you to see faces. It's important that we see faces. So if you lose that part, you lose the ability to recognize anybody. You go, oh, that's a face. You don't even recognize yourself in the mirror. Crazy stuff. Okay, and then your temporal lobe. Your temporal lobe is right here on both sides. Right inside of your temporal lobe is your hippocampus. That's why it has to do with memory. It has to do with hearing. It's right by your ears. It has to do with, basically, if we took off your temporal lobe, your limbic system would be right inside. So there's a lot of crossover in your limbic system. There's also some weird stuff. They just keep finding that your brain isn't truly specialized. There are other weird things that your brain does. If we can get one particular part of your temporal lobe, we can give you an out-of-body experience. Just all kinds of crazy stuff. So, but that's really all you need to know. This is the basics. We're not doing all the neuroscience and all this stuff. We're just doing what are the basic things: memory, hearing, and emotion. And there's a really important part for language in your temporal lobe. There's a really important part for language in your frontal lobe, and we'll get to that in a little bit. The way I remember temporal is it's right by your temple. So your temporal lobe is right underneath your temple. Frontal lobe is in the front. Parietal and occipital, maybe Mr. Davis can give you a good one for those two. I just do the hard part and remember them that way. Okay. Now here is your somatosensory cortex. You can see right here, your somatosensory cortex. And this is called the homunculus, which basically means little Homo sapien. So it's this tiny little homunculus. And this is so weird to look at. So this part right here, this maroon part, brown part, whatever you want to call it, is in your frontal lobe. This part right here is in your parietal lobe. This is what they call your motor cortex. Now, your frontal lobe, it allows you to control your impulses. It also allows you to move, motion, motor. So your motor cortex, which allows you to move, is in your frontal lobe. So if we're looking at the motor cortex, if I come over here and I say, put a little electric charge on this part, you'll see it probably correlates with the wrist. I can make you move your wrist if I hit that part right there. I can make you move your hip if I send a little electric charge there. I can make you move your lips if I put a little electric charge over here. So what we see is this map just basically says what part of this part of your motor cortex aligns with this part of your body. Now, why the different sizes? Ask yourself that question. Why is the face so big? And basically from your shoulders to the tip of your toes is so small. Your face is almost the same size as all of this. Well, think of how many muscles we have in our face. We have 40 some muscles, I think, in our face. So the reason this is so big is there's so much that this has to do. I mean, in our legs, we have a couple of muscles. There's really not that much. So we don't have to worry so much. There's just not as much space needed for your legs. There's a lot more space needed for your hands and face. Look at your hands and face is at least half of the motor cortex, okay? And then you can see your tongue and all this stuff. So that's the motor cortex, and that goes, so this controls the right side of your body, this controls the left side of your body, it goes crossways, okay? So last thing I'm gonna talk about, I know I've already gone kind of long. Now this is your sensory cortex. This doesn't allow you to move, this is in your parietal lobe, this doesn't allow you to move, it allows you to feel, it allows you to sense. Now, I'm not trying to be dirty, but you will notice here, we have genitals. And genitals are in the sensory cortex because we do have feeling in our genitals. But notice it doesn't have the equivalent over here because we don't have muscles. We don't move it, but we do sense it. So you will see it's kind of interesting. Even with gums, notice gums aren't over here. We don't move our gums. There's no motion required. There's no motoring going on in our gums. We have feeling in our gums, but we don't have motion. So you can see this is the sensory cortex. This is the motor cortex. This is the sensory cortex in your parietal lobe. It allows you to feel. This is your motor cortex in your frontal lobe. It allows you to move. Now, what you'll notice, though, is they're right across the street from each other right here. So the knees are right across the street from each other. So this is what allows your knee to move. This is what allows your knee to feel. Notice your face is right across from each other right here. So this is the part that allows your face to move. This is the part that allows your face to feel. This is your motor cortex right here and your somatosensory cortex right here. Somat means body. That's where we get psychosomatic. Psychosomatic illnesses, your psych causes your somat to get sick, your brain causes your body to get sick. So this is your somatosensory cortex, your body sensory cortex in your parietal lobe, and your motor cortex in your frontal lobe. Went too long. Sorry about that. Take it away, Mr. Davis.